3D printing uses specialized equipment to create solid, three-dimensional objects from a digital file. The practice has been around since the 1980s, when Charles W. Hull invented the process and created the first 3D printed parts. Since then, the field of 3D printing has grown exponentially and holds countless possibilities. 3D printing is a process that uses a computer-aided design, or CAD, to create objects layer by layer. 3D printing is commonly used in manufacturing and automotive industries, where tools and parts are made using 3D printers. In short, 3D printers use CAD to create 3D objects from a variety of materials like molten plastic or powders. 3D printers can come in a variety of shapes and sizes, ranging from equipment that can fit on a desk to large construction models used in the making of 3D printed houses. There are three main types of 3D printers, and each uses a slightly different method. Stereolithographic or SLA printers, which are equipped with a laser that forms liquid resin into plastic. Selective laser sintering or SLS printers have laser that sinters particles of polymer powder into an already solid structure. Fused deposition modeling or FDM printers are the most common. These printers release thermoplastic filaments that are melted through a hot nozzle to form an object layer by layer. 3D printers use a layering method to create the desired object. They work from the ground up a pile layer after layer until the object looks exactly like it was envisioned. They are so important for the future because of their flexibility, accuracy, and speed, which make them a promising tool for the future of manufacturing. Today, many 3D printers are used for what is called rapid prototyping. "3D printers can fill a role in virtually almost every industry. They are not just being used for prototyping. Many 3D printers are being tasked with printing finished products. The construction industry is actually using this futuristic printing method to print complete homes. Schools all over the world are using 3D printers to bring hands-on learning to the classroom by printing of three-dimensional dinosaurs' bones and robotic pieces. The flexibility and adaptability of 3D printing technology makes it a game changer for any industry. For instance, 3D prints can use plastic to print rigid materials, like sunglasses. They can also create flexible objects including phone cases or bike handles, using a hybrid rubber and plastic powder. Some 3D printers even have the ability to print with carbon fiber and metallic powders for extremely strong industrial products. Some of the most common applications of 3D printing can be rapid prototyping and rapid manufacturing, which provides company with a low risk, low cost and fast methods of producing prototypes that allow them to test a new product's efficiency and ramp up development without the need for expensive models or proprietary tools. Then functional parts, because 3D printing has become more functional and precise over time, making it possible for proprietary or inaccessible parts to be created and acquired so a product can be produced on schedule. Tools. Like functional parts, tools are wear down over time and may become inaccessible, obsolete, or expensive to replace. 3D printing allows tools to be easily produced and replaced for multiple applications with high durability and reusability. Let's talk about models. While 3D printing may not be able to replace all forms of manufacturing, it does present an expensive solution to producing models for visualizing concepts in 3D. From consumer product visualizations to architectural models, medical models, and educational, of course, models and tools. 3D printing is part of the additive manufacturing family, as we have already said many times, and uses similar methods to a traditional inkjet printer, albeit in 3D. Additive manufacturing describes the process of creating something in layers, additing material continuously until the final design is complete. This term most often refers to molding and 3D printing. It takes a combination of top-of-the-line software, powder-like materials, and precision tools to create a three-dimensional object from scratch. The first step of any 3D printing process is a 3D modeling to maximize precision. And because 3D printers can magically guess what you want to print, all objects have to be designed in a 3D modeling software. Some designs are too intricate and detailed for traditional manufacturing methods. That's where CAD software comes in. Of course, modeling allows printers to customize their products down to the tiniest detail. The 3D modeling software's ability to allow for precision design is why 3D printing is being hailed as a true game changer in many industries. This modeling software is especially important to an industry like dentistry, where labs are using 3D software to design teeth aligners that precisely fit to the individual. It is also vital to the space industry, where they use the software to design some of the most intricate parts of a rocket ship. Once a model is created, it's time to slice it. Since 3D printers cannot conceptualize the concept of 3 dimensions like humans, engineers need to slice the model into layers in order for the printer to create the final product. Slicing software takes counts of each layer of a model and will tell the printer how to move in order to recreate that layer. Slicer also tells 3D printers where to fill a model. This fill gives a 3D printed object internal lattices and columns that help shape and strengthen the object. Once the model is sliced, it's sent off to the 3D printer for the actual printing process. Let's talk about the 3D printing process. So, when the modeling and slicing of the 3D object is completed, it's time for the 3D printer to finally take over. The printer acts generally the same as a traditional inkjet printer in the direct 3D printing process, where a nozzle moves back and forth while dispensing a wax or plastic, like polymer, layer by layer, waiting for that layer to dry, then adding the next level. It essentially adds hundreds or thousands of 2 prints on top of one another to make a 3-dimensional object. There are a variety of different materials that a print is using in order to recreate an object to the best of its abilities. For example, plastic material, the same material, for example, that the Legos are made out of, carbon fiber filaments. They are used to create objects that need to be strong but also extremely lightweight. We have also conductive filaments. These printable materials are still in the experimental stage though, and can be used for printing electric circuits without the need for wires. This is a useful material for wearable technology. We can have flexible filaments, which produce prints that are bendable. These materials can be used to print anything from wristwatches to phone covers. Metal filaments are made of finely ground metals and polymer glue. They can come in steel, brass, bronze and copper in order to get the true look and feel of a metal object. The wood filament contain finely ground wood powder mixed with polymer glue. These are obviously used to print wooden looking objects and can look like a lighter or darker wood depending on the temperature of the printer. The 3D printing process takes anywhere from a few hours for really simple prints like a box or a ball to days or weeks for much larger details projects like a full-size home. We have also different types of 3D printers depending on the size. The fused deposition modeling, FDM, that is probably the most widely used, and it's incredibly useful for manufacturing prototypes and models with plastic. The stereolithography, SLA, which is fast and uses an ultraviolet laser to craft the object within hours. The digital light processing, which is one of the oldest forms of 3D printing and uses lamps to produce prints at higher speeds because the layers dry in seconds. Then we have the so-called CLIP, continuous liquid interface production, which is amongst the faster processes that use VAT photopolymerization. This process utilizes digital light synthesis technology to project a sequence of UV images across a cross-section of a 3D printed part, resulting in a sharp, controlled curing process. The part is then baked in a thermal bath or oven, causing several chemical reactions that allow the part to harden. The material jetting applies droplets of material through a small diameter nozzle layer by layer to build a platform which becomes hardened by UV light. Binder jetting utilizes a powder-based material layered evenly along with a liquid binder, which is applied through jet nozzle to act as an adhesive for the powder particles. Fused deposition modeling, also known as fused filament fabrication, works by unwinding the plastic filament from a spool and flowing through a heated nozzle in a horizontal vertical direction, forming the object immediately as the melted materials harden. Selective laser sintering, SLS, a form of powder bed fusion, fuses small particles of powder together by use of a high power laser to create a three-dimensional shape. The laser scans each layer on a powder bed and selectively fuses them, then lowering the powder bed by one thickness and repeating the process through completion. Then we have the multi-jet fusion. Uses as whipping arm to deposit powder and